right now. First thing first, we need to load our guard model. Right. In here we use daily data, so we will not change the number because we cannot bear the risk of missing variables. First thing first, we need to calculate the first order log difference for Dutch mark. Choose Dutch mark. D log, first order log difference, equal name as DLDM. Okay. Turn off your calculators. You will have the first order log difference. Next step, we need to multiply the DLDM, the first order log difference, by 100. Use calculators. DLDM, double click, multiplied by 100. Name as DLDM, multiplied 100. Now we have our time series data. Once we have our time series data, first thing first, we need to identify our ARMA model or our preferred ARMA model. Do that. Use the graphic. We try to construct the correlograms. Choose the right variable DLDM multiplied by 100 or plot types. Time series property. Takes the box ACF and the PACF. Next step, we need plot. Now we have our correlograms. According to these correlograms, we have two significant values for the correlation coefficient, and the first lot and the third lot. In this case, we try to construct AR3 and AR1. In here, we need to use the overfitting procedure. Remember the box Jenkins procedure. For first thing first, we need to build the AR1 auto-regressive model with order 1. Do this category. Model for financial time series data. Model class of BIMA. Formulate. Choose the right variable DLDM multiplied by 100. Click OK. Change the order for your auto-regressive model. AR order 1. The parameter D is fixed D. Remember, change the parameter D to fixed D. The D here is the order of integration. In this module, we study the fixed integration only. Okay. Choose the estimation method to maximize likelihood. Again. Now we have our AR1 model. For the AR1 model, we need to pay attention to two estimation values. One is your t-value, highly significant. The second is your AIC, information criteria. What the information criteria is for? AIC, or information criteria, estimates the amount of information you lost in the estimation process. The smaller, the better. Next step, once we have an AR1, we need to diagonalize. To do this, we need to test. Test again. We perform the fundamental statistics. If your model is not misspecified, the residuals estimated from your model should be follow ID, right? Should be follow ID has no autocorrelation. So that's why we need to perform the fundamental statistics. Click the box, click OK. For the estimation result, you can see for the fundamental test, result is highly significant, we fail or we reject the null hypothesis. The null hypothesis for the fundamental statistics is your residues estimated from your model is follow IID. There is no autocorrelation. We reject this null hypothesis. Our residues has autocorrelation. If your residues has autocorrelation, your model is misspecified. So next step, according to the overfitting procedure, we construct AR3. Okay. And again, wait a second, we get our AR3. For the AR3, once we have this model, we double check the AIC and the T value for all the coefficients. For the AIC, 2.327. For the AR1, 2.3319. So AR3 has the smaller AIC. Your AR3 looks like your preferred model, but we need to run the fundamental test again for AR3. Test fundamental statistics. Okay. Now we fail to reject the null hypothesis of the fundamental statistics. The residues estimated from AR3 follow IID. There is no autocorrelation in the residues. Our model is not misspecified. Once we have our AIC, once we have our preferred model, next step, we try to perform the arch test. To perform the arch test again, for the task menu, test with the arch test, tick the box, with order 1. Right? You might ask how to identify the order, the optimal order in the arch test. We will discuss this later, but we will perform the arch test with order 1. Right? Is okay? We reject the null hypothesis according to the arch test. We reject the null hypothesis of all the coefficients for the log squared residues are equal to 0. So we reject the null hypothesis. There's arch effect. To identify the optimal number of logs in your arch model, the arch test, we need to estimate the residue from AR3. Tick the box, test, open the test menu, store in database, tick the box residues. Again, name as residues. Back to your data, you will have your residues estimated. Next step, we need to calculate the squared residues. To do this, we use calculator, choose the residue, power of 2. Okay. Equal, name as R2 squared residue. Once we have a squared residue, we will construct the correlogram. To do this, graphic, remove, choose the right variable R2 into the selection menu. All port types, time series properties, ACF and PACF, port. Now we have our correlogram for the squared residue. We have 6 significant autocorrelation coefficients. 1, 2, 3, 4, 5, 6. So the optimal order for your arch model should be 6, or the for your arch test, it will be 6. There's no efficient way to identify the optimal number of lines in arch. That is a weakness for arch model. So you should try use the overfitting to try different number of orders. In here you can use arch 6 or even arch 10, right? Next step, once we have identified the orders, perform the arch test again. Test. Arch test with order 6. Okay, we get our results. For the arch 6, highly significant. Estimation result is 13.365. Right? Our estimation test, arch test result suggests you'll have an arch effect in the residue. Next step, we will construct an arch model. To do this, we need to change the models, the category, model categories to the models for financial data. Financial data? Okay. For gauge model. Okay. Formulate. Choose the right variables, ELDM multiplied by 100. Click OK. Now is for your gauge orders. For gauge model, in here, this model is gauge 11. The P, the order of P is for the last term of squared residues. Right? Squared residues. Sorry, the P is for the last value of conditional variance. The Q is for the order, number of orders of last squared residues. If we cover this bit, your P, order of P will equal to 0, and the Q equal to 1. So cover this bit, we get arch 1. Arch 1 is the gauge 0, 1. Right? Any questions? No? Right. Now, what we're trying to do is to construct arch 6. To do this, change number of P to 0, Q to 6. Okay. The rest are the same, right? Okay. And again, now we have our arch 6. Arch 6, we have 6 orders and 6 flat orders. Once we have our arch model, we need to perform the fundamental statistics again. But in this time, we will take the box square the residues. For arch model, we are dealing with square the residues. When we build the other model, we are dealing with residues. So in this case, we need to take the box square the residues. Click OK. The result shows your arch model are misspecified. There's autocorrelation in your residues. How to overcome the problem? There are 2 ways. One, we construct gauge. Another way is change the number of orders. So we're gonna construct our gauge model. For gauge model, okay, change the order 1, P to 1, Q to 1. You will construct the gauge 1, 1. Right? Okay. And again, we have our gauge 1, 1 model. Once we have done the gotcha 1-1, first thing first, autocorrelation test. Our tests, we fail to reject null hypothesis. There's no autocorrelation in the residues. Our model is not misspecified. Next thing, once we have identified our model is our preferred model, we should perform the exclusion restriction. We repeat the exclusion restrictions test for each of your coefficients. We need to get rid of all these unnecessary lines. Okay. We get a significant value here. We fail to reject the null hypothesis, the coefficient for alpha 0 is equal to 0. So we reject the null hypothesis. The alpha 0, the coefficient alpha 0 will be not equal to 0. We keep the coefficient. We repeat the test for each of the variables. It sounds like we're gonna keep all of them. Test again. We need to keep all these observations. However, if we construct arch 6, construct a gauge 2-1. Here we get a gauge 2-1. We perform the exclusion restrictions on the coefficients alpha 1, alpha 2, beta 2. We will have an insignificant value. Right? We should exclude the beta 2. Right? That's how the exclusion restriction works. Back to our original data. Construct the gauge 1-1. We have our gauge 1. Let me check. Once we have our gauge 1-1, the gauge 1-1 has number of weaknesses. First thing, the gauge model treats the market effect equally, right? So, as we discussed in our seminar, the gauge 1-1 gauge model cannot capture the leverage effect. Gauge 1-1 do not capture the concept of high risk, high return. So we need to construct our E-gauge and the JJR gauge. For the E-gauge, they take the natural log for all the parameters. In this case, it allows the negative coefficients. Remember, for arch and gauge, we are dealing with squared residues. There is a non-negative condition for the coefficient. So a gauge 1-1 model is an arch with unlimited orders. You can see the derivations in your lecture notes. But in here, we will construct E-gauge first. To capture the leverage effect, we need to construct E-gauge. Models, write variables, tick the box E-gauge. Okay, and again, now we have our E-gauge model. You might write this equation down, right? For the coefficient, all the coefficients, alpha 0, your estimation. This result is for the constant. EPS minus 1 is for your beta, and your absolute value EPS minus 1 is for the lambda, and also is for the alpha is beta minus 1, right? Beta 1. It's for all the coefficients. Once we have our E-gauge, we need to double check on the coefficients of EPS minus 1, which is the coefficients for the constant gauge. EPS is for the EPS will be for lambda, right, for the gamma. Unfortunately, we have an insignificant value. So what do we have? If the insignificant means your E-gauge model cannot be hoped. Right? We need to construct the JDR. The JDR gauge model also captures the leverage effect, but it's with a dummy variable. Right? IT is your dummy variable. If there is a negative shock in the market, your IT minus 1, the dummy variable will equal to 1. Positive shock, or otherwise it will equal to 0. Right? Assume there's a negative shock in the market, the mu t minus 1 is negative, your IT minus 1 dummy variable will equal to 1. Get squared mu t minus 1. So your conditional variance, the volatility will increase. Right? Otherwise, it's equal to 0 for the positive shock. This item will be gone. So for the positive shock, your conditional variance will remain the same. For the negative shock, higher volatility. Positive shock remain the same. That's how the JDR works. To construct a JDR model, JDR gauge, choose the right variable, untick the box of E gauge, change, open the gauge variations, threshold gauge is your JDR. Threshold gauge is your JDR. Click OK, and again, we get our JDR gauge. For the threshold, the coefficient for your threshold is the coefficient for the dummy variables. Right? In here, our dummy variable or threshold is also insignificant. The JDR model might not be, it's not suitable for our data. So next step, we're gonna construct gauge mean. What is gauge mean? In finance, higher risk generated higher return. Gauge model cannot capture this concept, so they introduce gauge mean. Gauge mean, all the gauge model has two equations. One is conditional mean, another one is conditional variance. Right? The equation 1, conditional mean, we have put the conditional variance, your risk, into the estimation of conditional mean. Right? Higher risk, your return will be higher. Right? That's how the gauge mean works. For the conditional variance, it remains the same for gauge 1, 1. Right? To construct a gauge mean model, again, open the verifications, choose the untick the box of threshold, tick the box of H, T in mean. H for the heteroscedasticity. Right? Tick the box, click OK, and again. Now we have our Gaussian mean. Gaussian mean, the coefficient is highly significant. The HT, the coefficient HT is the coefficient of beta in your conditional mean equation. So we have conduct the gauge model, the arch model, gauge model, E-gauge, JDR, and the gauge mean. Next step, we try to make forecast. How to do forecast? We use the estimation icon here. We need to change the number of last forecasts to 14. It means we will take these 14 observations out of the estimation product. We make a reservation for the forecast. For example, if your sample is 100, then we take 14 observations for the forecast. The number of observations used in your estimation process is 86. Right? Click OK. Now we take the test menu, open the test menu for the forecast. Again, we Because our number of reservations is 14, so we can make a forecast 14. Right? We can use the number of forecasts is 14. Click OK. This diagram shows you the forecast error. The blue line is your estimation, the forecast value. The red line is your actual value. The green line here is your range of fluctuation, your conditional variance. According to this diagram, we can see our forecast error is quite large, but we cannot compare with we cannot use diagrams to make a comparison between forecast errors, so we need to see the actual value. To do this, forecast, okay, change the option, write results instead of graphing. Tick the box. We will have 4 indicators. All these 4 indicators is for your forecast error. The error mean, the standard deviation of error, and the root mean of squared error. Finally, we get a mean absolute percentage error. If you have a different model, you will generate a different forecast error. Your preferred model should generate the smallest forecast error. Right? Smallest forecast error means your model, your forecast are more accurate. Right? That's all for Practical 3. You still get around 25 minutes. Please do some exercise on your own. If you have any questions, raise your hand. I will solve it for you. Right?